Okay, so I think this is the 6th installment now of our ARPG tutorial in Pygame. We're just going to add collisions. We've got our character, we've got them animating, we've got them moving around, we've got tiles, and we're just going to add collisions now. So here we are with exactly the same code as we had before. And we're going to go into our character class. So we had this base NPC class where we can add logic to. And we're going to put the collisions in here because we want the collisions to apply to all NPCs as well, really. And by default, the player can inherit from it because we can pass it into the update method. So we'll put it before the physics, the physics to be the last thing. So what I'd like to do first is to get a list of collidable sprites. So let's set off the function. So I'm going to get the collidable list first. So it's cheaper, or more efficient rather, to check collisions with the inbuilt sprite collide function of Pygame, but that only works with the rectangles, but we want our hitboxes to collide. And we can't really do that without using the rect functions. So let's get a list using the more efficient way first, and then we can just loop through that list, lot smaller list of those sprites for our collisions. So this is a function that will output a list, and then we can add collisions. So let's get started. We're going to pass a group of sprites in here. So for example, our block sprites from the scene. And then our collidable list is equal to Pygame sprite collide self. So that would be the character. The group, that would be the group that we pass in here. And false just means that sprite will not disappear when it collides. So the inbuilt function allows that to, when they collide, to disappear. I think that's correct. And then from here, we just return the collidable list. So then we can use that in our collisions function. So we want to pass a direction in here. We'll call it axis, X or Y. We want to pass the group in here because we want to loop through this list here. So we can go for the sprite. Start again. Collide list group. So again, if we pass a group here, it will call it on this. For example, the block sprites, which we're going to be using to test our player collisions against the blocks. And then we'll use our hitbox. Sprite.hitbox. So therefore everything must have a hitbox. If axis is equal to X, so that's the X direction, and let's pass for now. And then, so we want to add a hitbox in here. So for the NPC, we're going to have a standard hitbox. So we'll put it just under here because it relies on the rect. So the hitbox is just self-rect.inflate, and then you just put the width and height that you want to inflate by here. So my images, I think, are about 32 by 32 in size. So that would be the rectangle because it gets the rectangle from the image size. So 32 by 32 pixels. And I think the image itself is roughly about 16. So I just need to inflate this by half. And then all we do in the update function is center the hitbox on the rectangle. So the hitbox follows it round, and that's used for the collision functions. So here, we'll just halve the width of the rectangle. And the same for the height. We will inflate it by minus. If we don't put minus, it will just inflate it by half of the width outwards. So you could see the minuses deflate the rectangle in a way. And obviously this is height, this is the Y. So we want it separate to the rectangle, so we'll copy the rectangle and instantiate the hitbox as a copy of that. And we just need to change this. So this is how we are moving our rectangle around currently. Obviously want to move the hitbox around, and then we just want to center the hitbox, center the rectangle onto that hitbox that's moving around. So rect dot y dot hitbox dot center y. Okay, that should do the job there. Now we can start using these collisions. Let's just run it, make sure it's working. Yeah, still working. See, there's no collisions yet. Just want to put that player back on the top layer so we can. I'm going to put them on the same layer actually, on the same layer. First, I do kind of want. We'll leave that as it is. So the objects is in. Where were we? So blocks is in the layer of blocks. That's in the layer of characters. Let's put it on the same layer. So they're on the same layer. Okay, so these collisions here, we need to do something when it collides. So we've done that if it collides with the sprite, and we're using the hitbox, and if we're going in the X direction, then that's more than or equal to 0, and we're moving, that would be to the right, then sprite is equal to the sprite it collides with, hitbox left. So with that in mind, we better give this a hitbox. Oh, we did. I think we mentioned this in an earlier video, why we're going to be using hitboxes. So on top of this, I'm going to create a wall object. So I'm just going to give it a different inflation here. So wall, inherit from object. Okay. So I want to inherit from everything before. Let's inherit all these values. And then all we'll do is we'll change the hitbox. In the Y direction, I just want there to be some overlap there. So it's not going to collide until it gets halfway into the hitbox. Height. So that should be all we need for that. And then we can change it in here. Instead of instantiating an object, we can instantiate a wall, and it takes the same parameters. So that should be the same. Let's just check that works. Oh, we just missed this, of course. wall is not defined. Obviously, I always do this. From objects, we now enter the objects file. We've got object and we've got wall. So we just need to import wall as well, and then it works. Yeah, nothing's changed. But obviously, we're drawing on top now. The player is updating afterwards, so it's on top of the walls. Well, it's only the player that's updating at the moment. So, where were we? We'll go into the physics and we'll create our collisions with the walls. So, at the end of all this, we can just add our collision logic. We want to put the x-axis collisions first. So, in the collisions, we need an axis and a group. So, the axis is x. So, I'm going all over the place here. Self.scene.blockSprites. Not even finished this collision function yet, and I'm already adding it to the physics. So let's just go and finish the function off. So is less than or equal to. So if it's going to the left, then self.hitbox left is going to be equal to the sprite is colliding with hitbox right. And then I can just copy that down and change it for the y-axis. So if that's moving down, if y is more than or equal to 0, self.hitbox bottom should be equal to the thing it's colliding with hitbox top. So moving up, then the top will collide with the bottom of the what it's colliding with. Okay, that should give us something now. So we've got collisions X in here, and we obviously need the collisions Y in here. Oh, we do. We want the same collision sprites here passing in. We just want those to be done after the Y velocity, otherwise we might get some funny behavior. So we do all that X direction first, then check Y. Let's run it. Okay, scene has no attribute block sprites. Did I even call it block sprites? Yes, we don't have block sprites. So all these wall sections here that are being drawn, we need to add them into a group. So let's create that group. We don't want to be calling that collision on all the drawn sprites, we just want it on the block sprites. So now we've got the block sprites in our scene, which is a sprite group. We can add that into this list. So the wall is going to be a part of the block sprites and the drawn sprites. So now let's do it. And there we go. So up against the wall. Same again, it doesn't seem so choppy, so to say, when I haven't got OBS Studio running, but take it from me, it's perfectly fine. There's no bugs in this. You can hold all the directions and mess about. And as you can see, we give the wall hitbox Y value of half. So it gets halfway into the wall in the Y direction before it collides. Like that. So, however, there's a little trick we can use. I don't fully understand it, but it's something that ClearCode does in his tutorials and something I had read about, where you can sort each layer, you can sort the draw. So, for example, here we would like the player to look as if they were behind the wall, and here we want to keep it as this, where he's in front. So we can actually, if you imagine there's a tile here, and the player is here, we can draw the player behind it when the middle of the player is above. And then otherwise the player would be, the bottom half would be behind it, and the top half would be above. So it's being drawn in order of the Y position. So I hope that makes sense. Add that in now, and then we should be done with our collisions. So that needs to happen in our camera class. So if we go down to the camera, and then for sprite in group, and we want to sort this group by the Y, the center Y. So sorted. Group is the first parameter. And then the key is lambda sprite, and it's going to be the sprite ret center Y. And then that will draw it. Should draw it as we want it. So let's test that. There it is. So if the center Y is above the center Y of that tile, anything below it is drawn behind, and anything above is drawn above. Look. So that tile is above the center Y, so it's drawn behind. There we go. It was working there nicely, and it's working here. That gives that sort of pseudo 3D effect. Okay, in the next video, we'll go on to creating a character state machine. So that will open up a lot of things you can do with your character, and it'll make it really nice to code different features. There's more coding to actually do and more file management depending on how you do it. I'll show you one way of doing it, but you can just go straight into those different classes for each state and configure how you want the player to move and the characters and the enemies. And this is very fundamental to this being a scalable framework, so you can add enemies and you can create those state machines and just add extra functions without affecting anything else and keeping your code very tidy. So I hope you're enjoying it so far, and I'll see you on the next one. Thank you.